Hello everyone, we are Team Bimiko and our project for this course is an evaporative cooler. So let me walk you through the main parts of our assembly. Over here you see the cool room. Here is our desiccant box. This box is used to control the humidity, and over here is our evaporator. This is used to reduce the temperature of the air. Let me walk you through the process of our assembly. Uh, the cool air inside the box is circulated, is sucked through the return duct by a fan in the desiccant box, and then it is pushed through the desiccant box. When the air goes through the desiccant box, the humidity reduces, and the reduced humidity, the air with reduced humidity is then passed through the evaporator. Inside the evaporator, the evaporation takes place and the temperature of the air reduces. So, air that has a reduced temperature and reduced humidity is then provided to the room, and that process repeats as a cycle. There's another configuration in which we can use the cooling system, that is without the return lines in place. In this method, this is our inlet and this is our exhaust. The two fans suck the ambient air from the atmosphere, that is passed through the desiccant and then through the evaporator and then to the cool room. Then the air in the cool room is pushed out through our exhaust. Uh, next we'll walk you through each component in more detail. Thank you. This is the desiccant box that we used instead of the desiccant wheel. At the moment, we couldn't find a regenerative desiccant wheel because it's very expensive and hard to find. Uh, Instead of that, we designed a desiccant box. Uh, we have designed some desiccant meshes to place the silica gel particles. When moisture is absorbed, it turns into pink color. Originally, it is blue colored. We can place the mesh easily like this. Uh, then after saturated, we can remove the desiccant mesh and put it into the dryer and regenerate it and place it again into this box. Likewise, we can repeat the process. Also, we have used two fans. One is for blowing and other one is for suction. We wanted to increase the contact area with the air and the desiccant mesh. So we decided this mesh slots. Likewise, the flow goes in a zigzag way. In order to do that, we uh, created the slots with different heights. Uh, so first one is much higher than the second one. Likewise, we created the slots. These are the inner components that we used in our desiccant box.
Now let me walk through the evaporator that we use our evaporative cooling system. Uh, for evaporator, we use that for reduce temperature of the air that comes from the desiccant box before it goes to the room. Now let us have a closer look of our evaporator. Inside the evaporator, we can see the mesh that is made from water absorption material. For wetted this mesh, we supply water with gravity to wet this mesh.
So, as my colleagues mentioned, we decided we had to make a few changes from the original plans. One such change is the desiccant wheel. We had to omit the desiccant wheel because it was costly, and if we went to make a desiccant wheel, that would have taken much of our time. So instead, we went with the desiccant box method, uh, which proved to be successful, and also to provide water to the mesh. We originally planned to use a pump, but we couldn't find a pump that was suitable for our use. So we went for the gravity supplied method. If we had used a pump, we would be able to control the water supply to the mesh even better, and we would have been able to regulate the temperature even more. Uh, Finally, there's another change we had to make. That was we had to omit the heat exchanger that was in our original plans. We had to do that because if we went to fabricate an air-to-air heat exchanger, that would have taken that would have taken a long time, which we didn't have. So instead, we went without the heat exchanger. But if we had used the heat exchanger, we would have been able to reduce the temperatures even further. So finally, I would like to thank our supervisor, Ms. Lekha Bakmidaniya, technical officer, Mr. Anura, and the workshop staff, the engineering workshop as well for their guidance and support they have provided to us to complete this project. Thank you.